Hello and welcome back. In the previous video, we added our E2E tests to our CI/CD pipeline, and we actually started running them against a temporary dev environment that gives us the confidence that the E2E tests are being run against a real environment, not just a local copy of the server. And once we are confident that they pass, or once they are green, we just then and only then move on to deploying things to production. Now that we have a more solid setup for our E2E tests, and now that we have a more solid CI/CD pipeline as well, we can start leveraging the E2E tests for us to test more complex user interaction scenarios. And the first more complex use case we want to tackle here is a very, very important one, because at the moment, let's say I create a first task, and then I also create a second task and a third task. And the problem that I have here is that it all works fine. I can interact with them. However, the moment I refresh the page, I always lose the tasks that I have. So there is no persistence between refreshing the page or between also closing and reopening the browser. If I just refresh it here, you see all my tasks are gone. This is a major blocker for us, and we really want to make sure that at least in this browser here, at least in this window, right? So that the data is persisted whenever I close and whenever I open it again. So I'm not talking here about like creating a new user account and having a server that's going to store everything in the database, and then we can open this in some other browser and have the data as well. Here I'm just talking about that first very important requirement of please don't lose my data once I leave this browser window and I come back to it. And then once again, it's important to highlight that in the future, we do want to get to a state where we have a server running, where we can create accounts and add tasks and maybe configure things in the account. But for now, our focus in this, in the upcoming videos as well, is to have just a way that we can persist these tasks between refreshes and between closing and opening this browser tab. With that being said, let's come to our E2E tests, and we're gonna add something here. So again, maybe you're asking yourself, why don't you go to your unit tests here? And as it turns out, the behavior of reloading a browser page, it is more accurately represented by E2E tests. Okay, so the user journey here is a more complex user journey. So we are going to capture this requirement in the end-to-end test. Here I'm going to just copy and paste a few things that I already have here. So basically what I'm doing is I'm just creating a task with a text of first task, and I'm checking that it should exist on the screen. I'm going to copy this and I'm going to add a new it here. So it, and I'm going to say persists the tasks between page reloads. Okay, so that's very straightforward here. And I'm just going to paste this here as well. And now what I want to do is I want to reload my page. So I'll say cy.reload. So now I'm reloading the page, and then I would like to see my first task still on the screen. Now, as you may expect, this will cause the test to fail. I'm going to save this and I'm going to run the test :E2E local so that it's already all automated for me. It's going to spin up the development server. It's going to run the Cypress tests, and we should hopefully have a failing test so that we can actually go back to the production code and we can write something there. And there you go. We have here our failing test, and that's because it cannot find this first task on the screen after it reloads the page. So for the first version of this iteration here, we want a persistent storage, right? So this is what we're after here. So how are we going to tackle this? Is we have a tasks store already in our code. Let me open that. We have it here, use tasks store. And this is a store which has a simple in-memory state from React. We have this tasks store here, and this can then, whenever this is loaded, whenever this is first loaded, it can then go to our persistent storage layer and it can load all the tasks. Once it loads all the tasks, it stores the tasks in this tasks here this variable, and then it will show them on the screen. The second part is that when this tasks variable here, when this state is updated, we want to go and we want to save everything again to our persistent storage so that the next time we open the component, we actually get the latest version of the tasks. Now you might be saying it is extremely expensive to update everything whenever a single task changes, and I'm 100% with you, completely agree. But again, we are focusing on the problem at hand, and for the solution here, for the persistent storage, we are going to use the simplest persistent storage that we know, and that is the local storage. And because the local storage works only with strings, it would be quite complex for us to actually manage individual tasks in the local storage. It is possible, okay, but it will lead to a solution that is more complicated than it has to be. So for that, what we're going to do is we'll simply store a stringified version of an array, and that stringified version of an array is going to be updated every time a single task is added or changed in our internal memory. Once again, not the most efficient solution, but it will allow us to discuss a lot of interesting things. So we're going with this for now. And again, we are aiming at making the code as easy as possible to change so that in the future, when we want to update more efficient or when we want to implement more efficient solutions, we can do so without a lot of pain. So here is a slightly more detailed diagram of what's going to happen. We're going to open the UI. Right? We're going to render the tasks component, and then once we have this hook here, the component load hook, and actually in our case, we are not going to code this exact method here. We will just hook into a useEffect without dependencies. We'll get that in a bit. Once this stage is reached, then whenever we have this hook here in the UI, our tasks store is going to go to our persistent storage, and it's going to get all tasks, and once these tasks are returned, it will save the tasks in an internal tasks state. And then once this tasks state is updated, then we're going to show all the tasks on the screen. Now, one little word of caution here, it is important that we use the use state hook for these internal states, because an update in a value of a use state hook automatically triggers the re-render of a component in React. So we don't have anything else to do here apart from just saving the tasks that we receive from the persistent storage layer into this tasks state. Now the second part is we want to save the tasks whenever we create a new task, right? So now here we are on the UI, we're going to click on the create task or just on the create button, and we will add this task to our internal tasks state. Now we will set up another useEffect hook that has the tasks here as a dependency. So whenever this task's internal state changes, it's going to trigger the useEffect hook, which will then go to the persistent storage, and it's going to save all the tasks. Once that is completed, we then again just show all the tasks on the screen, and our work here is done. Now let's start with this first part, and there are a couple of challenges we'll come across, but we'll deal with them as we go along. So the first thing I want to do is I want to start run test watch, because I want to watch my tests and I want to make sure that whatever changes I'm doing here, I'm not breaking anything to my existing tests. These are not the Cypress tests, these are the unit tests, but they are a good proxy, so we want to make sure that they are running. They are all still passing. Word of caution, eventually we will reach a place where we're going to break some of the tests, and then we'll take a small detour to fix that before we continue working on the persistent solution. Right, so the first thing that we want to do here is we want to load, and let's go back here to the diagram, we want to load the tasks from the persistent storage whenever the component is rendered the first time on the screen. So this is done by using a useEffect and with an empty array of dependencies. Now let me take 30 seconds to explain what a useEffect hook does. And basically the useEffect is going to run this function, which is called an effect. It's going to run this effect whenever any of the dependencies mentioned here in this array change. Okay, if there are no dependencies mentioned here, the effect is going to be run only once whenever the component renders for the first time. If there are dependencies here, as we will see in a bit, then the hook or the effect here is going to be run every time that these dependencies change. So we want to load all the tasks from my local storage whenever I render the component the first time on the screen. So we're going to say here const tasks, or just to prevent some naming conflict here, we're going to say JSON tasks is equal to JSON.parse. And here we're going to take the things from the local storage, localStorage.getItem, and I'm going to call this tasks. Okay. Now you'll see that I have a warning here because this can be undefined and JSON parse doesn't work with it. Oh, sorry, null. Right, so the argument of type string or null is not assignable to the parameter of a type string. That means that JSON here is expecting a string. And for us, since we know that we are expecting an array here, let's make sure that if nothing comes back from our localStorage.getItem, we just give an array, an empty array back to our JSON tasks. Now what we will try to do here is we'll simply set the tasks here to the JSON tasks that we get back. Let's then save this and let's see what's going to happen to our test. These are just a couple of errors that are now gone. We are re-rendering them here at the bottom. And let's have a look if everything is still working. Everything is working fine. So basically we're just loading this item here. And then if this is not defined, we are just passing an empty, a string representing an empty array that is then put into the JSON tasks that is then saved on our internal local storage, the tasks, sorry, not internal local storage, but our internal state, the tasks variable. Now we need to go to this second step that happens when we click on the create task, that we add something to the internal tasks state, and then whenever this task's state changes, then we save these things to our persistent storage. So back here in our code, we're going to add again yet another useEffect, and this useEffect is going to be responsible for saving stuff to our local storage whenever any of its dependencies, and in this case only the tasks dependency here is what is important for us. So whenever the tasks dependencies change then we want to save this to our local storage. How do we do that? Local storage.setItem, that's going to be again tasks, right? And here we will simply say json.stringify, and that would be our tasks. Okay, so quick word of caution, whenever I save this, I'm going to have some problems, and I think pretty much the whole remaining of this video is going to be to solve these problems in an elegant way. So I'm going to save this, and let's see if things start breaking. I would like them to, and then we can actually fix them. Perfect. I think I'm the only person who will say perfect when things are failing, but perfect. That's what we expected, or at least that's what I expected, that a couple of things start failing. And if we go up here, we start having a little clue about what's happening. So here you see that it says task.getTitle, and this is the line of error, and it simply says task.getTitle is not a function. Now, this is not super useful for us to identify what's happening here. For us to understand where the problem is, let's try to console log on this line here, right? Let's try to just console log the result of us parsing whatever is in local storage. So I'm gonna write a couple of console logs here. So just for us to understand what is being saved and what is being loaded from our local storage. I'm gonna say console log loading, and maybe here let's be a bit more use tasks store loading tasks from local storage. Okay, so I'm just gonna console log that I'm doing this, and then here we're gonna say use task stores saving tasks to local storage. Yeah, to local storage. And then here what I want to do is I just want to console log the result of json.stringify. So I'm going to say console log and then json.stringify. Once I save this, it's going to run again at the bottom here, but now we will have a few more console logs so that we can try to identify what is going wrong. All right, things are failing again. That's good. Let's scroll up here, and here it's printing all the errors before, but if we still keep scrolling up, then we can actually see if there is anything exactly. So here we have saving tasks so loading tasks from local storage. This is what we are getting. And here we are saving tasks to local storage. I'm saving nothing at this specific task, but actually here we have a bunch of things. So here we are saving tasks to local storage, and then we get what we are saving, right? So here you see that we are saving an object where we have a JSON representation with an ID and a title. And then here, whenever we are loading this from the local storage, we are actually parsing this. So this is already the result. This is an array already in JavaScript of objects. The problem here is that this is very different from the internal data structure that we actually use to represent a task, right? So we use a class to represent the task, and this is just a key value object. So this is very different from the task or from the class that we have here. This does not have the getIdentifier method. This does not have the getTitle method. So whenever we are trying to call them, and you see here in the error message, if I just scroll down here, you see that it's trying to call this task.getTitle, and it's just not working because it's not there, right? What we are returning here when we are actually loading the things from the local storage is simply an object containing a key of ID and a string, and also a key of title and another string here. Now, this doesn't give us all the methods that we expect to have whenever we are using the task class in our components. So we gotta have a way of transforming between objects that have this shape. So they are just key value pairs. So to transform between them and between our class of task. And this is something that goes beyond the local storage issue, because this is how communication happens over the network. We don't really send task JavaScript classes here to our backend, because our backend, first, we don't want to do that because our backend may not be in JavaScript, may not be in TypeScript, so it doesn't know how to interpret these things. But the second one is that whenever we serialize this, whenever we transform this into JSON, we lose all the information regarding the methods that we have. All the synthetic sugar here goes away, and we have, in the end, just a very, very straightforward key value pair here. So we just have a very straightforward object. So this is an issue that goes beyond the local storage. It is great that we are seeing this already with local storage, because then it means that we can already tackle this in a more, let's say, a more robust way. But this will also happen whenever we need to pass tasks, for example, to the network. We would have to have a way of encoding the tasks into this format and then decoding this format into our task class. This process of encoding and decoding is actually called serialization and deserialization. So that's what we're going to implement here. I'm going to create a type, and I'm going to say the type is going to be serialized task. Okay? So serialized task is going to be this JSON representation of the task. For us here, it contains an ID, and this ID is a string, and it contains a title, and this title is also a string. Okay, so now we have something that you can see here. This is very close to what we have here. It is an ID with a string and a title with a string. The next step now is for us to look for a way of encoding and decoding tasks and serialized tasks, or actually communicating between these two ways of representing a task. So for me here, the way I'm going to do it is that I'm going to create a static, and actually, yeah, let's create it here. So we're going to create a static method, and we're going to call this serialize. And the serialize method is going to take a task of type task, and this task here is of this class, and this will just return for us a serialized task. Okay, and actually here maybe I can try to use the arrow function just for the sake of consistency. I think that works, right? So here it is complaining in a bunch of places, because first, this is not being used. Second, this is not being returned, right? So here I'm just going to return an object which has to contain an ID, and for now an empty ID, and the second one is a title, and for now an empty title. So now most of our warnings are gone. All these are prettier warnings. Don't worry about them. They are not making any harm. But here now the idea is that I'm going to have the task. So here I have task dot get identifier and then task dot get title. Once I save this, now you see that there is a method that we can call, and this method does not belong to any of the specific objects. This is a method that belongs to the class task, and it just allows us to pass whatever task we want to pass to this method and get a serialized task as a result of calling this method. Now, this could be an instance method as well. I could simply just have it like so, right? So serialized, and then that would be called from a specific task. Honestly, because we will have the deserialized method also being static, and that we have to have it as static, for the sake of consistency, I do find it alright to use this representation where both the serialized and the deserialized methods, they are static methods. Okay, for implementation purposes, I don't think that the difference is really big. So I'm just going to follow more for consistency. So now we are implementing the deserialize method. We're just going to say deserialize, and that is going to be, again, an arrow function that returns us something. It does take a serialized task, and that is of type serialized task, and it returns us a task as a result. Okay, so now here we're just going to return new task, which is going to take the serialized task dot title. Okay, so now here you see that we have both the serialize and the deserialized methods, and we can use this to transform a task into a serialized task and to get back that task from a serialized task. Now there is just one thing missing here, and that we need to have a way of passing the UUID, and that we can do it very easily by just adding an optional parameter again, and if the ID is defined, then we're going to use it. Otherwise, we will just generate the ID based on the UUID v4. However, I'm actually going ahead of time here because I'm writing production code that does not have a failing test to actually be motivated for it. We'll actually go back to this, and I just realized that we don't have any specific tests for the models, but we will test this behavior of already passing an ID here in a test for the model. So in a test for the model, task model class, right? It's confusing to say these things, but now anyway, let's move forward. We are still trying to fix this specific problem here, that we are not able, oh, there's a lot of errors, but that we are not able to save or correctly save and correctly retrieve things from our local storage. Okay, but now we have the methods that we actually need to achieve that. I'm gonna save this, and then here in my use tasks store, what I will do is, instead of having the JSON tasks here and just saving this in my tasks, what I will do is I'm gonna map over this array, okay? Map over this array, and for each element here, I'll simply call the task.deserialize task. All right, so now what I'm doing here is, and that's probably, I think, a prettier, or is it complaining that it doesn't have, okay, it doesn't have the type. So that's gonna be of type serialized task, and I need to export this from this. So this is not yet exported. I need to export this, and now I can import it here. Right, so now each task that comes from the JSON object is a serialized task, and once I pass the serialized task and call the deserialize method, then this is gonna give me back a task class, right? So it's gonna give me back a task class, which can then be set here. You see that there are lots of like assumptions here, because we don't really have anything like the JSON.parse here just returns us an any, and we don't have any way of knowing that all these things are like properly typed. If we change something here and we don't save the tasks correctly on the store, or if we change the schema of tasks and we have old tasks stored in the local storage, then this is not telling us anything about the validity of, or about the correct behavior of our code. So this is a somewhat tricky thing to work with. We'll keep that in mind, and maybe we can consider implementing a solution for that. But for now, we're actually good to actually just save this and see if the tests are gonna start passing, or they are gonna start behaving in a more predictable way. All right, so we have we have more tests failing than we had before, but if we scroll up here, we see that the message is very different, right? So you see here that we have a difference in terms of the expected length, and this is actually, if we come to the task, so which one is this one? Test the app root component. That is not correct. That should be the tasks component, right? That's better. And the problem here is, you can see at the bottom, we have an expect of tasks to have a length of 2, but it's actually receiving 9. And the problem here is that we're running multiple tests and we're not properly cleaning up the local storage between tests, right? So this is basically accumulating all the tasks we are creating over all the tests, and then the later ones start to fail. A simple way of doing that is just before each of the tests, not before all, but before each, we will simply run a cleanup function that's going to say localStorage.clear. Okay, so that's just going to clear up the whole local storage, and if we are storing anything else in the local storage, that will also get cleared up, which is okay, which is good, because in a unit test scenario, we want to ensure that we start every test clear from scratch. Okay, so all the environment, everything that is persistent is cleared up, and we start clean from the beginning. Now, if I scroll down here, let's have a look at what happens. Now all our tests start passing again, so we are actually good to go here, because we have managed to find a way of actually converting between this object representation with an ID and a title and the class representation, where we have additional methods that we can work with. That is great. So now we have some leeway here that we can do a bit of refactoring. I'm just going to remove the console log. I'm going to remove the console log. And then the last thing I want to do here is I just want to make sure that I am properly converting the tasks into our serialized version before stringifying them. So I'm going to say tasks.map. And then the task here, an individual task, I will simply say task.serialize my individual task. Okay, so that is just making sure that we are consistently transforming the tasks into their serialized version, and then we are stringifying this, we are saving this in our local storage. Once I save this and all the tests run again, they should still be green. There should be no surprises. And we can actually move to our models here. We can create a new file, and I'm going to say task.test.ts. And this here is going to be specific to the model, or to the class task. Okay, so I'm going to call this describe, and I'm going to say tests the task class. And here, I actually want to write a failing test so that I can address that ID problem. And I'm going to say it should keep the ID when saving and loading from the persistent storage layer. Okay, so when saving to and loading from the persistent storage layer. And that's actually not the correct description, because we're not saving anything here. We're actually, it should keep the ID when serializing and deserializing, when serializing and deserializing the same task. Okay, so like here, the concept of a same task is basically just the concept. Oh, and why is there one failed? Because I don't have anything. Yeah, all right, that's fine. That's still not a problem. That's because I just added a new file here. Anyway, let's go back. So the concept of a same task here is just, I want to call the serialize and then deserialize on the same task. So let's again refine a little bit the description. Should keep the ID when calling serialize and deserialize on how can I call it? On the result, or yeah, on the result. I don't know how to call it. On the result of the serialize call. Okay, so like basically should keep the ID when calling serialize and deserialize on the result of the serialize call. That is super confusing. So I'm just gonna say here in sequence. All right, whatever. Let's move forward. And here, what we actually want to do is we just want to create a task, right? So that's gonna be new task, and we need to pass a title, and that's gonna be my title, right? So now here we're gonna say const serialized task, and that's just going to be task.serialize task. Okay, and then here we'll say const deserialized task is equal to task.deserialize the serialized task. So basically what we are doing is we are creating something, and then we are serializing this, and then we are deserializing it. And what we would expect is that deserialized task dot get title equals, right? So what is that? To be, exactly, to be the task dot get title. So we expect them to be the same. Once I save this and execute everything, I believe that everything is going to be in order now, because this is still passing. Like we are still passing the title here. Exactly, so everything is good. But now, once I have the expect deserialized task.getIdentifier to be the same as the task.getIdentifier, this will actually break, because whenever I'm deserializing the task, if I come back to my tasks here, I am just passing the title, which means that I'm regenerating the ID all the time. So you see that it's already failing here, and they are not the same. So once again, a quick way for us to do that is to simply pass here an ID, right? So that is an optional argument. And if this ID is provided, then we're gonna use it. Otherwise, we're gonna generate it. And then here, what we want to do is we want to return a new task with a serialized task.title and a serialized task.id. Once I save this, that should be enough for us to make our test pass. Perfect. So now we have documented a little piece of behavior, which is super important for us, because we want the identifier to be stable whenever we are saving stuff to a persistent storage layer, and whenever we are retrieving these things from the persistent storage as well. All right, this video is already quite long, so let's take a little pause, and in the next video, we're going to revisit our use tasks store, and we will see how we can apply some best practices of software development to make the design of this function better and more robust. Thank you, and I'll see you in the next video. Bye bye.